Let's do these problems. We want to find the antiderivative of g of x equals 30x minus 12 if we know that the antiderivative goes through the point 0, 10. And we also want to find the antiderivative of that same function, g of x equals 30x minus 12, if the antiderivative goes through the point 1, 8. As we did before, we start by taking the indefinite integral of the function expression that we're trying to find the antiderivative of. So that means we're going to integrate 30x minus 12 with respect to x. This gives me the indefinite integral becomes 30 divided by 2 times x squared minus 12 times x plus c. 30 divided by 2 is more commonly known as 15. So I am going to simplify this expression to 15x squared minus 12x plus c. That is the form that the antiderivative takes. I'm going to call the antiderivative capital G of x. For this problem, we know the point 0, 10 is a point on the graph of the antiderivative. Notice plugging in 0 is really nice. The output is 10 when you plug in 0 for x. And when you plug in 0 for x into a polynomial, then a lot of times what happens, just as in this case, a lot of the terms go to 0. 15 times 0 squared minus 12 times 0, that part all gets converted to a 0, and 10 would equal our constant. That means the antiderivative we were looking for is capital G of x equal to 15x squared minus 12x plus 10. Again, it's nice to plug in the value of 0 into polynomials because many terms go away when we do that. We can start the exact same way if I had known that the antiderivative goes through a different point. Namely, let's say the antiderivative goes through the point 1, 8. We would start the same way. We'd find the indefinite integral, and we would know that the antiderivative has that form. Again, the form is capital G of x is equal to 15x squared minus 12x plus c. We know this 0.18 will work in our equation, so we plug it in. The output is 8 when the input of x is 1. So I replace every x with a 1. 1s are pretty nice too, because 1 squared gives you 1. 1 times anything is itself. If I simplify and combine like terms on the right-hand side, I would end up with 3 plus c on the right-hand side. Subtracting 3 from both sides yields a constant number, which is 5. In conclusion, this means that my antiderivative would have been 15x squared minus 12x plus 5. That's the antiderivative we were looking for. That's how to do problems that involve getting specific antiderivatives. Most of this section is going to be focused on doing the indefinite integral, or otherwise known as integrating a function, but you can utilize integration in order to find specific antiderivatives if you get another condition. So that's it for this section.